Hello everyone, today we will talk about what configuration settings are required for the DHCP server. First, we need an IP address range. We need to know exactly which IP addresses will be assigned to this particular server. We need the associated subnet mask for that IP address range. We also need to determine how long a workstation can retain the same IP address. We will do this configuration setup for the shortest possible duration. We also need to configure the DHCP server with DNS server settings so that your directives can be configured with the appropriate DNS server, IP address, and default gateway settings. If you're using something like a voice over IP server, it's a good idea to include its options along with all other IP configurations. When a DHCP server assigns an IP address to a device, it selects an available address from the address pool you previously configured within the server. For example, you might have a subnet pool with a value of 192.168.1 but a slash of 024, which means anything in that subnet can be assigned an IP address from the DHCP server. These IP ranges are typically very large contiguous ranges of IP addresses, and your server simply pulls from any available address within that range. But sometimes you may want to set up reservations or exclude certain IP addresses from the range, and you can certainly create these exceptions within the server. This is a server running on a Windows Server device. The range specified here is 165 to 45 to 44.0. Under that range, we have a series of address pools, so we know which IP addresses will be assigned. There are address leases, so we can look at previously assigned IP addresses. IP reservation can be configured. If a device should always receive the same IP address, this can be configured in this section of the server. We have scope options that allow additional parameters to be configured. For example, we want to add the IP address of a voice over IP gateway so that when you use DHCP in your home or small office, all devices on the network know exactly which IP address to contact. Maybe your server may not be on a Windows device. It may be on the embedded router. This is the web front end of the embedded router, showing that the network with the DHCP server enabled has a starting address of 10.10.10.2 and an ending address of 10.10.10.100. Therefore, we can expect the server to assign addresses starting at point 100 on this date. This date server specifies the address minus the time in seconds, which is a bit unusual. But if we know that 86,400 seconds is the same as 24 hours, then this configuration works fine. The gateway is configured as 10.10.10.1, and our DNS configuration will also be assigned to our local device. Therefore, any device on the network that requires an IP address at boot time will receive an address with these specific configuration values from this DHCP server. For most devices that connect to a network and receive an address, they are receiving a dynamic assignment. This means they can receive any IP address from the large pool of IP addresses we configured earlier. After your lease expires, these addresses will be available to others connected to the network. Many DHCP servers will also have an auto-assignment feature where a list of everyone previously connected to the network will be kept. If you connect to the network again after a brief absence, it will remember your previous assignment and, if that IP address is still available, it will assign you the same IP address as before. You can also take it a step further by configuring IP address reservation, which means that a device connected to the network will always receive the same IP address, and that IP address will never be assigned to another device. On the Internet, this is typically configured based on the MAC address or the Media Access Control address, that is, the address burned on the network interface card. Each device has a unique MAC address, which allows us to associate a device with a specific IP address. You may also see this referred to as static DHCP allocation. Static allocation or IP reservation. Below are some DHCP reservations from my DHCP servers on the Soho network. You can see the MAC address listed along with the IP address, and the hostname of this device is Prometheus. I have another device listed by MAC address. You can see this is a different MAC address. In the original version, it got a different IP address and the hostname of the device was Odyssey. This means that when Prometheus starts, it will always receive an IP address of 192.168.1.6 and that IP address will never be assigned to another device on that network. When a device dynamically assigns a DHCP address, this is a temporary assignment. After a certain period of time, the device must be checked into the CPU server again. Let it know that it is still using the same IP address, otherwise, the lease will expire and the IP address will be available for someone else to use. The length of this lease is determined by configuration within the server. We see the lease time as 24 hours on my DHCP server, but you can configure this to whatever you want via admin. If you reboot the device or leave the network and then return, a reassignment process also occurs and it renews the lease and continues to use the same IP address. There may be times when you want to administratively or manually release the IP address, hand it back to the server, and then leave the network or request a new address from the DHCP server. When the device receives the IP address from the DHCP server, a timer is started for the length of the lease configured for this DHCP server. We mentioned earlier that once the lease timer expires, the IP address is returned to the server and can be assigned to someone else. But there are other timers you should be aware of during the rental process. One of them is called the T1 timer. This checks the DHCP server halfway through the lease time. So if your lease is 8 days, this T1 timer, which defaults to 50% of the lease time, will check after 4 days and let the server know that we want to keep this IP address for another lease period. At this point, the device resets to 8 days and we begin the countdown again. But sometimes the DHCP server may be unavailable and you cannot check in after 4 days using the T1 timer. If the DHCP server never returns to the network by that date, the lease time will continue to count down. Once it reaches 7/8 of the lease time or 87.5% of the lease time, it will attempt to rebind to any other DHCP servers it may have on the network so that it can retain that IP address. This is the T2 timer that gives each device on the network a chance to retain its IP address by rebinding to a redundant DHCP server. Let's visually see how this DHCP process happens. Assume that in this particular network, the lease time is 8 days. This means that your T1 timer, if it takes 50% of that time, will be 4 days, while your T2 7/8 timer will be 7 days. Let's look at this device that has been assigned an IP address. Each of these blocks is the 4th day or a day after that. 50% of the time has elapsed and the T1 timer has been turned off. It wants to renew this IP address by contacting the DHCP server and telling it that it wants to renew that specific lease. Once the process is completed, the timer will restart and another rental process will occur. However, during the second lease, the original DHCP server is no longer available, so we cannot check in after the T1 timer completes. This means we'll be all the way into the rebinding period for T2 timers, or in this particular case, after 7 days have passed. Once we are able to contact that redundant DHCP server after the T2 timer expires, the process starts again from day 1, with 8 days left on our lease. Okay, that's it for today.